All right, so I think we'll skip around a little bit today in terms of the order that the slides are on. This kind of part at the beginning is an interesting discussion, but you have that homework that's due at the end of the week. So I want to make sure I give you kind of everything that you would need so you can get a little bit more time early to work on that. Some of the other stuff that I know won't be as relevant to some of those problems, I'm going to kind of hold off for to go over on Wednesday. So we'll come down here to after it says conclusion. We've got this oligopoly slide. Okay. So we left off, or last Friday, we were talking about monopolistic competitive markets, and we kind of compared them to perfectly competitive and monopoly markets. So another one, it's a little bit more specific, is what we'll call an oligopoly. So all it really means is that there's a few people selling, right? So monopoly is one seller. Oligopoly means there's very few, right? So you kind of imagine when we had the perfectly competitive market, we said there was like thousands or at least, a significantly large number of firms. Here we're going to be looking at markets where there's only a few. So you kind of imagine they might have some market power, just like a monopolist, where the monopolist, we said, we'll use this too. Kind of set this higher price and lower quantity, right? If we're comparing that to kind of the perfectly competitive market, and I think instead of high and low, actually, I kind of thought about this as like this highest, prices at its highest, price at its lowest when it's perfectly competitive, and then quantity is maximized under a perfectly competitive market. Quantity is kind of at its minimum point under a monopoly. So oligopoly is going to be kind of somewhere in between, right? And we'll talk about maybe some areas where maybe it gets pushed to look more like a perfectly competitive market, and then sometimes it might get pushed to look more like a monopoly, right? Or it kind of floats somewhere in the middle there. Okay? So we can have oligopoly markets where the product is either exactly the same or it's differentiated, kind of like monopolistic competitive. We said even things like brand names can cause differences in demand for certain products, right? They're not perfect substitutes. So we can kind of think about each firm is still trying to maximize profits. But because there's only two firms, what they do, right, their supply to the market can greatly influence what that equilibrium price in the market is. Okay? So each firm has a pretty significant effect on the market, right? And when it comes to their quantity decisions. Like we could say, so it's not all the same. We're going to be talking about just a couple examples. And if you were to take intermediate micro, we'll dive into a lot more and more complex oligopolies. But for us, we'll kind of just look at a couple major ones. So we'll first start out with when we're looking at oligopolies that have homogeneous or the exact same product, so a perfect substitute. We'll start out even not with multiple firms, but just two. Right, so we'll start with what we call a duopoly. There's just two firms. Okay. Now, the same principles that we'll talk about would apply that if there was like 3 or 4, and they all had homogeneous products. But we'll just do 2 to kind of make it a little easier. So each firm, if there's only 2 firms, you would want to make sure that you have the lowest price, right? Because if you think about it as, I don't know, let's say there's only 2 gas stations in town. Whoever has the lower price, that's who people are going to choose to go to, right? Or at least more often, depending on the circumstance, right? So it's always good. If we're offering the exact same product, it's always best for me to have a lower price than you. Okay. So kind of to spoil the end result, and we'll kind of talk through how we get there. But when we have 2 firms or 3 or 4 firms and exactly the same product, a homogeneous product, we end up kind of with this perfectly competitive output or perfectly competitive outcome, which is that the price is equal to the marginal cost. So remember, when we had these perfectly competitive models, we had this marginal cost. Firms' marginal revenue was just whatever that equilibrium price was in the market because they had no control over it. And then we said we were at that minimum point on our average total cost curve. So our long run equilibrium, the price was exactly equal to marginal cost. And actually, this ended up being true in the short run as well, which is here we'll kind of look at long run. We said for the monopolist, right, and I probably should be putting my Y and X axis labels up there. So they kind of face some marginal cost curve. However, they have or face this twice as steep marginal revenue curve because they face the entirety of demand and they're the only ones supplying. So we said they choose the optimal quantity be here, but the price they set will be wherever we were at up on our demand curve. So the price ended up above marginal cost, right? We said we had, in same thing with monopolistic competitive, we had this markup, right? Price was above marginal cost, causing there to be some deadweight loss in the market. On a perfectly competitive market, we have price is exactly equal to my marginal cost here. So write this out here. So how would a duopoly, when they should have some market power, they should have influence over the market, how do we end up with this outcome where we get the price to be exactly equal to the marginal cost? So let's kind of go through this, right? So think about you got two firms, it doesn't matter what product they're selling, but one of them is selling it for 50, the other one lowers their price to 49, you know, making this like the easiest example, like I said, a town with only two gas stations, they're right in the same corner. You see the price is lower at one, you go to that one, right? Exact same product. So, who's everyone going to buy from? Firm B. So firm A sells a quantity of 0. I mean, assuming that everyone, you know, there's not like a, you know, we can make this more like, oh, someone's in a rush and they don't want to wait in line. But if it's able to everyone kind of pull up, get gas exactly when they want and leave, everyone's going to want to choose firm B. So firm A will essentially have a quantity of 0 sold, which means their profits will be 0, right? They're not selling anything. Okay? In fact, the profits would probably be negative because I'm assuming there's some large fixed costs that might exist to have that gas station operate. Okay? So everyone chooses firm B. So what do you think firm A is going to do?
Lower the price.
Lower the price, right? Probably, you know, if we're doing like dollar denominations here, I guess it was gas stations, maybe it goes penny by penny, but just for the sake of this example, they probably would lower it to 48, right? If they lower it to 49, they would maybe split demand with firm B, but if they lower it to 48, well, they know that everyone's going to buy from them, right? They're going to increase their quantity, right? Just taking a little bit off of that price, sacrificing a little bit from price, having a lower price. If I'm now getting everyone to buy from me, I'm really increasing quantity. Well, that's going to more than compensate for that reduction in price. So you kind of think about that profit equation. We said was the quantity they sell times the price minus average total cost. So yeah, the price going down is a bad thing, but if the quantity increase is even greater than that, well, then my profits will go up, right? And we know that quantity will go up a lot because if I can have a lower price, I'm going to steal all of that demand from the other firm. Okay? So this would kind of continue, right? What happens the next day? Firm B undercuts until the point when price would be exactly equal to the minimum point in the average total cost curve and profits are 0. Because at that point, if I lower the price anymore, my profits would then become negative, right? So it would just actually make sense for me to sell nothing, right? At that point. So this kind of process of if you have the exact same product, you're going to come back and forth undercutting each other's price until we get to that point where we're both charging the same price, we're both getting half of demand, and we're kind of our price is exactly equal to our marginal cost, right? We can't set it any lower because we know if we do, we're going to have negative profits. Okay. So that's kind of the uninteresting example with a duopoly is that we kind of end up with this point where price is equal to marginal cost. Now, I put up here, I was thinking of a duopoly, kind of assuming that they go through this competition down to this point where price is exactly equal to marginal cost, but there still can exist profits if there were barriers to entry, right? So in this duopoly, right, it could be that they face kind of half of the demand curve, right? So you kind of think about maybe the market demand curve is up here, but each firm with only two firms is going to get half of that, even if they're charging the exact same price. And then basically it goes back to kind of solving this like a monopolistically competitive market where they're going to both set, we'll kind of call this the oligopoly price. They would both set the price and quantity kind of just like we were solving for monopolistically competitive firms. And then you think about maybe the average for cost, something like this. So it could be that they kind of operate with positive profits, but if that existed, firms would enter the market. Well, if there are barriers to entry and they can't, firms aren't able to enter this market, potentially there still are positive profits for oligopolies, but it's not the most common kind of case, because if there are barriers to entry, a lot of the times those are regulated, right? Where kind of the government steps in and makes sure that firms can enter and exit these markets at will. That's not open for. I won't try to trick you with that. The more interesting that I want to get at is how could there be positive profits that exist if these firms cooperate? So even if we have a scenario where, let's say, these firms have zero profits, right? So I drew an example they have positive. Let's say they kind of go back and forth, lowering their price, and the final kind of equilibrium price is equal to marginal cost, and it ends up being equal to their average minimum of their average cost curve. They've got zero profits. So that can happen, but if they can coordinate their actions, they can then actually increase profits. So I'll just give you some examples of how we can think about this. So let's say I've got these different price quantity combinations. Right? This kind of represents the relationship between demand. At these different prices, here's how much is demanded on the market. Well, if we had a monopoly in this market, we could calculate total revenue, right? Just price times quantity. Okay? So that's all that column is. I could also kind of calculate my total cost. Now I'd have to be kind of given some formula or told what these costs are. Here I'm telling you what these costs are at these different quantities. So when I'm selling, you can kind of see there's variable costs here, right? If I'm selling more units, it's going to increase my costs. Okay. I can then calculate profit. Here we have a profit equation, but where did it originate? We said there's really two equations that we can look at for profits. Erases all over here. The other way we could think about profits is just total revenue minus total cost. So that's how we can kind of come up with that column. So if I'm looking here, what quantity would I want to produce if I was a monopolist here? Yeah, one. Because our profits are highest, right? So that would be what we would think about as the monopolist's profit maximizing quantity. So 60, and then at that quantity of 60, what price can they get away with charging? That price of 40. So that's kind of where the monopolist would go. If we look here, we're thinking about what marginal costs are. What if this wasn't a market that was monopolized? Well, we said marginal costs, marginal anything, is just take the total of what you're looking for the marginal of. So marginal cost, use total cost, marginal revenue, use total revenue. So you look at the change in those total costs divided by a change in quantity. So I kept these numbers all kind of nice. So notice every single time I guess we'll start here, increase quantity by 10 units, how much is cost going up by? Every single time, 100, right? So here I kept marginal cost constant just to make it a little bit easier. So as I increase 10 units every single time, my change in quantity would be 10. Every single time I'm going up by 10 units, I just said, notice 500 to 600, 600 to 700. The change in total cost is 100. So I've got a marginal cost of 10. So we know that if this wasn't a monopolized market, we have two firms, they're going to keep lowering their price because when they have the lowest price, they get all of demand. Now they do this until they get to the point where they can't lower anymore. We said kind of where their price is equal to that marginal cost. So here, if I'm looking, where does price equal marginal cost? Well, my marginal cost, we just said was 10 for every single one of these quantities. So price equals marginal cost at that quantity of 120. Okay. Now, that's like the long run, right? Maybe initially one of the firms, they kind of start out with higher prices, but over time, as they undercut each other, we get driven down to that point where prices equal marginal cost. And we have long run profits there of zero, just like the perfectly competitive market. Yeah.
So let's say, instead of the cost changing by 100 each time, like, let's say it was like all different.
Yeah.
How, do I find the change in total cost from, like, if let's say I'm looking for 10, would I go from like 5 to 10 and then?
Yeah, so let's say, let's go 130, 120, 10. I'll keep the quantity change the same, but let's say we had total costs of something like that. I could calculate the marginal cost for every single movement. So the way that you think about it is, I'm always thinking about the additional costs. So it's always, what's the additional cost from producing more? All right. So here, we can kind of see price quantity combinations written in either direction. But here, my marginal cost, like to increase quantity, I'm kind of moving upwards, right? Going from 110 to 120 to 130 units. So what I'll always do to find my marginal cost, another way of thinking about this is, I'm going to write it out and I'll explain it. So you can think about it as, you'll take whatever the, put high and low here to kind of think about, I'm going to be using the total cost and the quantity that are higher, right? Like I'm moving to a higher quantity and a higher total cost. So those are like my new total cost and my new quantity. And then, I'm subtracting where I was at before, or the lower quantity and the lower corresponding total cost. Or like I said, another way of thinking about this is new minus the old.
So it would be, in terms of total cost, it would be 1,000 minus 750.
So here, I would actually be able to calculate two marginal costs. The marginal cost of producing 120 units, right? Going from 110 to 120. So there, how much would, so here I'll not have any room over there on the right, so I'll put it on the left, but how much are total costs going up when I go from 110 to 120 units? 50. So when I'm finding the change in total cost, 50 divided by the change in quantity, 10. So here I would have a marginal cost of 5. To calculate the marginal cost of 110, I would need, the quantity.
Yeah, that's what I was wondering.
Yep. And then here to calculate the marginal cost of moving from 120 to 130 units, well, total costs are changing by what, 200? Change in quantity is 10. So there my marginal costs are much higher. So then here, we just had to look for where the price is equal to 10. If I had it changing, we're basically looking to see, well, where did the price, we have another column, price, where did price and marginal cost end up being the same, right? Here, if I created a marginal cost column, it wouldn't be very interesting because I kept it all to be 10. Yeah, right. Any questions? But if that helps you, like if you wrote out a marginal cost column here, where you get 10 every single time, well, where would price and marginal cost line up? Right, where price and marginal cost is 10. Questions? Any questions? So, what if these two firms could come together and agree on how much they should both produce, right? Like if we could coordinate our actions, where would profits in this market be at their maximum? Well, we know that kind of the monopolist is able to extract the most surplus that causes deadweight loss for society, but monopolizing the market maximizes profits, right? It can increase profits to its highest point. So if the two firms could come together and say, look, we know that if there's 60 units provided to the market, we could get away with charging a price of 40. Total profits in the market would be 1,800. Well, if we're both gonna split profits, like we each produce 30 units, right? So that if we each produce 30, we know there will be a quantity of 60 on the market. Then we could split these profits of 900. So that's the idea behind it. They coordinate their actions. Instead of getting driven down to this point where profits are zero, they can act as a monopolist together. Okay. So we call this collusion, right? And you kind of, I know you've heard this term, right? It has a negative connotation because it's the idea that if we collude our actions, it's better for both of us, right? Both of the firms, it's good for them, but bad for consumers, right? There's a great, what's it called? The League. If you've never watched that show, it's a pretty funny fantasy football show. And yeah, and there's a whole episode about collusion. So we've got these different quantities, right? We said that both firms would produce 30, so there's a total quantity of 60 on the market because we're looking at duopoly, two firms. The corresponding price they were charging is $40, and from that table we said they'll split the $1,800 of profits even. Okay. This is good for them, right? They're colluding, things are great. Okay.
So they're both producing 30.
Yeah, so remember, this was telling us all of demand. We know that where profits are highest are where the total quantity in the market's 60. Well, if there's two firms, we'd have to both produce, split that. So instead of we both produce 60, well, now we're back up where the total quantity in the market is 120 and profits are zero.
Right.
So we have to agree to both produce less, right? Like we both have to produce less, but by doing that, we've restricted the supply in the market and driven the price up a lot. So that was kind of what we saw if they colluded. Here I'll use kind of the example of cell phone companies. There's pretty strong evidence. It's not like they necessarily talk to each other, but they look at each other's actions. I actually was just looking at this the other day because, well, whatever, you don't care. But I might be switching phone companies. But they're like, if you want the exact same attributes, if you look at Verizon, if you look at T-Mobile, you look at AT&T, they're literally almost identical in costs, right? They might have some features that vary, but if you want the exact same features from each of them, it's going to be the exact same price as all three. Like if you look at their base model prices, that's the easiest one because it strips down all the additional stuff. They're all the same. So why is that the case? Right? Well, because they know that if they coordinate their actions, they all have the same price. They're all going to be, or they're going to be able to restrict the quantity on the market and all enjoy better profits. Right? I mean, if all three companies have the exact same price for their product, it might as well be a monopoly, right? That there's no competition. So anyways, so we'll think about this example of cell phone because it's pretty relevant. Okay. So we'll just use two companies just to make it easier. Like I said, the same thing would apply to three. Here we'll just use two. And that's where I'll kind of refer to T-Mobile and Verizon. Okay. So let's say they're coordinating and they're acting as a monopolist, each producing 30 and then splitting the profits, right, of 1,800. So they both get $900. Well, what if T-Mobile's like, okay, we've kind of been going through this thing. We've both been charging the same price, providing the same amount, or which kind of results in a certain quantity of phone plans in the market. But I know that if I kind of break away from that agreement or I renege on that agreement and I increase my quantity just a little bit, right? I'm going to sell a few more plans, right? I'm going to, sell a few more phones, whatever kind of however product we're thinking about. Well, now if I'm selling more, if the price was the same, well, I would then increase my profits, right? But because there's only two firms, when I supply to the market, that influences market supply a lot. So if I'm producing 40, let's say T-Mobile kind of holds true to the agreement and still produces this lower quantity of 30. Well, what's the total quantity in the market? 30 plus 40 would be 7. So now, because there's a higher supply in the market, kind of the price that these firms are able to get away with charging is actually lower. Right? So we were coordinating, but T-Mobile kind of sneakily increased their quantity, which caused that market price to fall, that equilibrium price to fall a little bit. Right? Kind of like we thought about, even if we had a perfectly competitive market where we just had supply and demand told us where equilibrium quantity was. As supply got higher, that drove that price down. Same thing here, right? It's just that one firm, right, produced a higher quantity, so like an increase in supply, we saw a higher price. Right? So the new price is 35 because the total quantity in the market is now 7. So now let's analyze this, right? I put the kind of old profits if they had both stuck in the agreement, so we have a reference point. But if the total market quantity is now 70 and the price is 35, what are profits going to be? Well, both firms, right, are charging the same price, whatever their average total cost is. Here, we'll just assume they have a similar cost structure. So this will kind of be the same for both, but now the firm that's selling a higher quantity is going to have higher profits than the firm selling a lower quantity. So if we go back through, we can calculate total costs and total revenues again. We're looking at kind of price and average total cost, keeping marginal cost constant at 10. Allowed me to have a constant average total cost. You don't have to know that to worry about that, but that's essentially how I know what the average total cost is. If my marginal cost is always the same, I'm paying $10 every unit, well then my average total cost is always going to be whatever that changes. Like I said, you don't necessarily have to know that. I'm keeping marginal cost constant for that reason. We just know that that 10, that marginal cost of 10 will represent my average total cost because I have the constant. So that gap in between price and average total cost is 25. For T-Mobile, the one that kind of sneak behind the back of Verizon and produce a little bit more, they're selling 40 units, so their profits are 1,000. Well, that's great for them, right? Because before, when they were splitting profits evenly, and they were both restricting quantity to 30, they only made 900. So there was an incentive for T-Mobile to kind of, yeah, I'll produce a lower amount and then renege on that agreement. As soon as they broke from that agreement, if Verizon stayed true to it, they're going to end up with higher profits, right? Notice, sorry, so we could go through the same thing for Verizon, but instead it'll be what, $25 times 30 units, right? Which would actually be a profit level that would be lower than that. Right? So if you're the firm that kind of sneakily increased your quantity, it'd be good for you. The other person would kind of eat into their profits. The problem is Verizon knew this exact same thing as well, right? So they undercut, if they decided to kind of sneak behind or, break the agreement and produce a higher quantity of 40 as well. Well, now both of them are producing 40. So the total quantity in the market is 80. So it would drive the price down to 30. Right? So now if I calculate profits, well, now the price is 30 minus my average total cost. Both firms are selling 40 units. And if they both break this agreement, they now both only get profits of 800. Whereas if they would have stuck true to it, they could have both had 900. Right? So, but there's always this incentive that if I'm the only one that breaks the agreement, I can increase my profits. The problem is we both have that incentive to break the agreement. So if we both break it, we end up in this worst scenario. Okay? So this is kind of good for us as consumers, because if these firms act on their own self-interest and kind of bite on these incentives to break these agreements, well, then what does the equilibrium become? Well, they both just keep trying to be the one that breaks the agreement more and more, and we end up back at this point, right, where price is equal to marginal cost, right? So it doesn't matter necessarily if firms can collude, because we know there's always going to be this incentive to be the one that breaks away from that collusion agreement. The problem is the models do become a little more complicated. For our sake, we'll kind of hold to this model, but to just give you some more application, the only way we can get away with kind of not falling victim to this situation where we both break from the agreement is if we know that there's going to be repeated kind of like the market's going to be repeated every single year, and that there might be some reputation that if we both hold true to this agreement, I might know the other person will never break away from it either, right? But if I ever think that the other person might break away, then it's always best for me to be the one who breaks away first, right? And then we kind of end up in that scenario where we're back at that perfectly competitive market, even though we have a duopoly, because they keep kind of trying to undercut the price of each other, or always be the one that has a little bit higher quantity produced. So, we can think about, this gets kind of driven down. I already mentioned this, right? They go instead of 40, well, now they break the agreement and go to 50, and we get back all the way down to this point where. Oh, sorry, I'm skipping ahead. I'm saving this for after the exam. I forgot I had the extra slide in there. So that's all I want you to know about duopolies is kind of that. If they could collude, they can act as a monopolist and enjoy higher profits. But because there's always self-interest, there's always incentive to be the one that breaks the agreement. We end up in this scenario in the long run where they're looking like a perfectly competitive market and prices set equal to marginal cost. So where are we at on time here? Okay, perfect. So that's what I want you to know about oligopoly. So I think what we're going to do, I'm going to skip around a little bit. Like I said, some of this I'm saving for, it's more game theoretical stuff. But I believe we can think about some of these iClicker questions. So we'll kind of walk through some of these with you. And I've got one more thing I want to show you with equations and monopolies that we can walk through. So I might give you questions like this in the exam. In fact, some of the practice problems look very similar to this. But let's say I gave you this price quantity combination. I gave you the revenue, and you then calculate the marginal revenue for you here. The numbers are kind of big, so. First thing we're going to look at is if this was a competitive market and a long equilibrium, what would the price be charged and what would the quantity be that's provided in the market? So we're thinking about this being a competitive market. I'm kind of referencing the perfectly competitive market. So we know that in the long run, price should be equal to marginal cost. We know that here I've got what? The marginal cost is constant at 50. All right, so I'm just looking to see where does that price equal 50. So I know that in the long run, perfectly competitive markets, price will be equal to marginal cost. I've kept marginal cost constant here. I said, suppose the marginal cost of switching on cable TV like this is constant marginal cost of just 50. So I got 50 as my marginal cost. So I would go through here, look at this price at 50. How much would be produced in the market? 1,100. So 1,100 would be the quantity provided in the market. Lost my train of thought. So that's all I need, right? I know that the equilibrium price would be whatever that marginal cost is in the long run for a perfectly competitive market. And then I just go to, okay, if that's the price in the market, what's the total quantity that's going to be purchased? So that one's not too bad. What if they acted as a monopolist here? We kind of worked through this one before. But I said, if I've got a monopolist, right, I know that they're actually going to want to maximize profits. What should be true about the price and quantity for the monopolist if they can coordinate their actions as opposed to this perfectly competitive market? The price should be, price should be higher, quantity should be lower. So first of all, I can rule some of these out right away, right? I know the price has to be higher. Well, that one doesn't work, right? I know the quantity has to be lower. Well, that one doesn't work. So I've already got this down to either A or B, right? Now from here, what's the difference as well? Monopolists will choose where marginal cost is equal to marginal revenue, right? So where does marginal cost equal marginal revenue here? Well, if my marginal cost was constant at 50, marginal revenue is 50 at a quantity of 6,000. At that quantity of 6,000 provided in the market, the equilibrium price would be what? 100? Yeah, so hopefully everybody who's paying attention, all right, should be able to get this one, okay? All right. Give you a little bit, a couple seconds if you're pulling it out to get these in. I think I counted 31. Okay. Everybody got their responses in here? Okay. I'll hold off until it's loading. So we have this kind of difference in a perfectly competitive market and a monopolized market where we've got the price is end up going to be lower. You got to go through. All right. I'm going to close it out here. So we're gonna end up with the price being higher, quantity being lower. So what we said was, if my clicker works here. There we go, all right? This higher price, lower quantity. Right? So what if we have a duopoly, right? If they're able to coordinate their actions and collude, we know that we're going to end up at this monopoly point, right? This price quantity combination that the monopolists will end up at. The only difference is going to be that if I'm thinking about how much can each firm produce here, well, remember, we still have two firms, they're just acting as a monopolist. So the resulting price will still be $100. However, now each firm will only produce what? 3,000. Half of what that total quantity would be, or 3,000. So this is how you might have some questions like this on those practice problems where you're given this table. You can kind of think about your perfectly competitive point. Where is price equal to marginal cost? In the long run for a perfectly competitive market, we know that will be the equilibrium. So we just look for, we have this constant marginal cost of 50, made it easy on you. Just look for where that price is 50, that's a perfectly competitive equilibrium. For monopolists, we know that their marginal revenue, right, is not just going to be whatever that equilibrium price is. So we say, okay, where does marginal revenue equal marginal cost? That's where profit is maximized for the monopolist. So that was that price quantity combination of 106,000. And then if we have a duopoly that's coordinating their actions, we're still going to end up at that same monopoly price. It's just that each oligopoly is only going to produce half of that total quantity of 6,000. Which is why for each one, they'd only produce 3,000 units.
The marginal cost was given to us in this.
Yeah, right. So I'm just kind of giving you here the marginal cost is exactly $50, right? It's going to be the same for every. So it's going to have this constant marginal cost. I think the practice problem even uses that term, like assume the marginal cost is constant at blank, right? Yeah, otherwise it would be more complicated. I'd have to calculate, I'd have to have a cost column, calculate my marginal cost. I won't throw all of that in, I'll kind of keep it kind of nice and constant. We kind of already did this last class, just kind of talking, and I have it up here, just kind of think about the movement between perfectly competitive and monopolized markets. Price is just getting higher, quantity getting lower as we move towards a monopoly from a perfectly competitive market. So we'll do one more thing. We'll get out of here. So let's think about something like this. Actually, I'll give you maybe if we do some review on Friday, I'll kind of throw in maybe an added thing you would expect to see in the exam, but for today, I'm introducing this, I'll keep it a little easier. So let's say that I've got this constant marginal cost, right? So I don't have this increasing marginal cost. I just got a constant marginal cost of 20. Really what I'm saying is no matter how many units I'm producing, the additional cost for all of them is 20 units. Okay. Let's say I then give you a demand equation. Let me think what I want it to be first. Let's do 100 minus 4Q. That's my demand equation. So if I was plotting this, I know that my demand curve, right, price and quantity, I'm going to start at 100, and then for every quantity I increase, I'm going to go down by 4. And that's the slope, -4. So I could plot all these points out if I wanted to. I don't have to, but just know that I have this kind of slope of -4. So if I was thinking about what my marginal revenue curve is, I think I might have kind of wanted to do something similar. What would my marginal revenue equate to? Close, not half of the demand. So let's think about where would my marginal revenue curve start? Same point. I think what you're saying, I think you're thinking about it correct. But we know that the slope would have to be twice as steep, right? So you're saying it's half of demand is close to correct. It's just that it's not actually half. Depends on the point you're at, how what proportion. But yeah, so it's twice as steep. So you know it's the exact same equation, but the slope is twice as large. Right? So 4 times 2, you have -8. So if I wanted to find the profit maximizing quantity here, what am I looking for from a monopolist? Sorry, I might have this. I'm showing you kind of how we would solve a monopoly model with an equation. So we know that the monopolist is going to choose the profit maximizing quantity where marginal cost is marginal revenue, right? It's always the same thing with profit maximizing. So if that quantity, right, how can I figure out what that is? Well, that's the point where my marginal cost is equal to my marginal revenue. I've got two equations for that. Where does that marginal revenue equation, what quantity will it equal 20? Well, I've got one equation, one unknown, it's just a little bit of algebra. So I can subtract 20 from both sides. I'm going to break this down to steps here. I'm going to add 8 to both sides. So, arrow here. 8q is equal to 100. Nope, not 100. 80, right? Then I divide both sides by 8. And I get that equilibrium quantity. Right. So I might expect you to do something like this in the exam. I would give you a demand curve, right? And then I would have to give you some constant marginal cost. Now you could do this if marginal cost wasn't constant, it would just be a little bit trickier, right? Because instead of having one value, I might have something like, I don't know, 2 plus 4q, right? It might be my marginal cost equation. Just makes the algebra a little more complicated. I'm not trying to trick you in algebra. This class isn't for algebra. So I'm more likely to kind of just give you this nice constant marginal cost. Right? So there's my profit maximizing quantity. How do I figure out what price I can get away with charging? Yep, I go up to my demand curve. So what do I do now? Yeah, I've got this quantity of 10. Well, what's people's marginal benefit at that 10th unit? Well, that's just my demand curve. Like that's what that reflects to me. So all I have to do is go down here, plug that 10 in. It's my demand equation. I'm just plugging this value of 10 into my demand equation to figure out what point I'm at. Yep. So it's like that's going to be at a price of 60. Okay. So you can find the kind of profit maximizing quantity price for monopolist. Here, I could actually find it for the perfectly competitive market as well. How would I do that? Well, we said marginal costs, supply reflects marginal costs. So the perfectly competitive market is where marginal cost hits demand. So what do I do there? Marginal cost is equal to my demand curve. So 20 was my marginal cost. Here's my demand curve equation. Now I do the algebra here, solve for what this equilibrium quantity is. You get thinking what 20, 80 divided by 4. So right. Yep. That quantity for the perfectly competitive market would be at 20. Well, and there the equilibrium price is pretty easy. We actually know that in the long run, for a perfectly competitive market, I think I might have erased it now, but earlier I had price is equal to marginal cost. Marginal cost is where my price is going to be, right? Wherever I'm at in that demand curve. So it ends up being a quantity of 20. Here we'll call this the price of the monopolist, price of the perfectly competitive firm. Point that we're at in our demand curve there. Oh, price is marginal cost. Exactly what we know is to be true about perfectly competitive market.
And then we could also figure out deadweight loss from this as well, right?
Yeah, this one you could, right? So what would deadweight loss be? It's a good point. How could I calculate deadweight loss? I could ask you for something like that too. How can I calculate deadweight loss here?
Well, the base of the triangle is 10.
Yeah, so where is deadweight loss? It's the loss of surplus from selling fewer units. Well, what surplus is lost? It's that area between my supply and demand curve. I'll get out of the way for you people on the right. So it would be that kind of triangle on the right there, right? So here, my deadweight loss, what's the height of that triangle? Going from 60 to 20. What's the base? 20 minus 10, right? The difference in the quantities. And then it's a triangle, 2 times 1/2. So here I have what? 20 times 10. That clear where I was getting all these numbers from? This is just the height of that triangle, right? going from 60 to 20, 20, the base of my triangle, 20 to 10, and then it's a triangle, so multiply by 1. Questions on? So, I think that set us up pretty good. We've got some market concentration statistics that we'll kind of talk about on Wednesday. We'll also go over a little bit of monopoly competitive kind of branding stuff. And then we might even have time. I might start doing some exam review Wednesday, and then Friday will be all for exam review for the in-class exam on Monday, the 7th. Okay. All right. See you guys on Wednesday.